Imagine having to do mechanical work without the use of electricity. Our jobs would be slow, tedious, and much more labor-intensive. Electricity makes what we do a lot easier and a lot more efficient. Unfortunately, it also makes what we do somewhat more dangerous. There are more than 20,000 electrical accidents and 700 electrocutions in the United States every year. Many of these occur in the mechanical construction and service industry. In fact, electrocutions are the fourth leading cause of death among the construction trades. How can you avoid becoming one of these statistics? By understanding the electrical concepts of path to ground and path of least resistance. By keeping your power tools and equipment in good working order. By using ground fault circuit interrupters, or GFCIs, when necessary, and by recognizing work situations that are particularly hazardous and knowing how to handle them safely. In an electrical circuit, the electricity flows from a power source through a wire to the tool or unit that uses the power, and then through another wire back to the power source. If you somehow become a part of that circuit, you have a real problem. For example, if you touch an energized bare wire or part of an energized electrode holder that's not insulated, you're going to get shocked. How badly you get shocked depends on how much current actually passes through your body on its way to ground. That's because electricity always travels through the path of least resistance to earth, or ground. And it travels through the most conductive material available to it at the time, even if that material is a human body. Your average 110-volt line carries between 15 and 20 amps, but it only takes around 70 to 100 milliamps to kill most people. Now, if you were using a power tool with a bad cord and you happened to touch an energized bare wire while standing on a wooden floor, you might be lucky enough to only get a painful shock. However, if you were standing on a damp or wet concrete floor, you could get electrocuted. That's because water is a natural conductor, and a good one. The water would make you an even better path to ground and increase the amount of current running through your body. Here are some things you can do to make sure you don't become the easiest path to ground. Keep your power tools in good working order. If you've got a crack, cut, or scrape on a power cord, don't use it until you can have it repaired by someone qualified to do it properly. If you've got a tool with a cracked or broken casing, don't use it. And always store your power tools properly. Over time, the insulation around the cords and other parts of the tools can become weather-beaten and rotten if they're overexposed to the elements. Many electrical accidents happen in the workplace simply because power tools and equipment aren't properly grounded. Check the plug every time you get ready to use a power tool or equipment. If the plug is supposed to have 3 prongs and the ground prong is broken off, don't use it. You don't want your body to take the place of the ground wire for that tool. The same things hold true with extension cords. Inspect them for nicks or cuts and for missing ground prongs before using them. If the plug is designed as a 2-prong plug, that means the tool is probably double insulated and doesn't need to be grounded. Check for wording on the equipment itself that tells you it's double insulated. If there's no writing, look for the double insulation symbol. It's one square inside another. If it's a 2-prong plug and you can't find anything that tells you it's double insulated, assume it's not safe to use. No matter what kind of cord, power tool, or equipment you're using, if it's defective, tag it and take it out of service immediately. Most companies have a place designated for depositing defective tools and equipment. All extension cords are not created equal. They're made with different gauges of wire depending on their intended use. For example, a regular household extension cord isn't heavy duty enough to use with most power tools. It would get extremely hot and could even melt because it's not designed to carry that much current. So check the rating on your extension cords before you use them. Once you're satisfied with the integrity and quality of your equipment, take a good look around. Are there any sharp corners or jagged edges that could scrape, cut, or puncture the cord while you're working? If so, do whatever is necessary to protect that cord before you start the work. Here's an inexpensive piece of gear that has saved a lot of lives over the years. It's a ground fault circuit interrupter, or GFCI. The GFCI can detect even the slightest difference in the amount of current flowing between the power source and a power tool or piece of equipment. If the current changes by as little as 5 milliamps, the GFCI automatically trips the circuit. 5 milliamps is way below the electrocution threshold of about 70 to 100 milliamps. A ground fault circuit interrupter won't prevent shocks, but it will prevent severe burns or electrocutions. For instance, suppose your drill was plugged into a GFCI and a piece of sheet metal sliced into the hot or neutral wire while you were working. The ground fault circuit interrupter would sense the change in the amount of current flowing between the power source and the drill and automatically trip the circuit in about 1/40th of a second. You may get a painful shock, but you won't get killed. Ground fault circuit interrupters are standard in many job sites, but if they're not available where you're working, carry a portable one with you. Follow this sequence when you're using a portable GFCI. It's critical. First, plug the GFCI into a grounded outlet. Next, plug your extension cord into the GFCI, and then plug the power tool into the extension cord. This GFCI is a lifesaver, literally. When you're working a mechanical construction job site with temporary electricity, you've got to be extra careful. Wires may be hanging low overhead. There may be outlets that aren't grounded. There may not be any built-in GFCIs. Carry a circuit tester with you and check to make sure the outlets you'll be using are properly wired. Checking is quick and easy. Plug in your circuit tester and read the lights. Don't use the receptacle if it isn't properly wired and grounded, and let your supervisor know about the problem immediately. And if the ground fault circuit interrupters haven't been installed, use your own. These two pieces of equipment are pretty cheap life insurance. And if you have to use a portable generator during the day, make sure that it's been properly grounded. Also, be careful when you're using ladders around temporary wiring. It's easy for a ladder to contact low-hanging wires and expose you to a severe electrical shock. That's why it's smart to use non-conductive ladders. They'll help insulate you from the current and help keep you out of the path to ground. On many sites, construction managers and general contractors won't even allow metal ladders. Non-conductive ladders are made of fiberglass or plastic. Dry wooden ladders aren't great conductors, but when they're wet, they can be extremely conductive. Temporary wiring can also be hazardous to workers using aerial lifts and mobile scaffolds. When you're maneuvering around workers and other obstacles on the floor, it's possible to miss what's going on up above. Before you know it, you could be in contact with live wires. Pay close attention when you're operating or moving this type of equipment around temporary electricity. And it's not just inside that you have to be careful. Fortunately for us, most of the heavy equipment operated outside the building is handled by another trade. However, on occasion, some of us have to go outside to use a piece of equipment to reach high spots or move materials. Using equipment like cranes, aerial lifts, or rough terrain forklifts around overhead power lines can be dangerous too. Those lines carry enough current to kill you many times over. And remember that electricity can arc. You don't have to actually touch a high voltage line to have your equipment become energized. If you have to work near overhead lines, get the power company to cut off the power. And make sure they lock out the power switch so it doesn't accidentally get turned back on while you're working. Even then, assume that all the lines are live and treat them accordingly. Keep your equipment as far away as possible and never any closer than 10 feet. If it's not possible to de-energize the lines, have a qualified electrician cover them with an insulated barrier. The good news is, if a piece of equipment does become energized by a power line, the operator usually isn't in danger unless he or she tries to leave the cab. Even though the ground around the equipment is probably energized, you won't become the easiest path to ground if you stay in the cab. The bad news is that other workers in the area around the energized equipment are also in danger. Make it a habit to stay clear of cranes and other types of heavy equipment being operated near overhead power lines. You never know when the equipment, or the ground beneath it, could become energized. Working with live circuits has its own set of hazards. Obviously, if you are servicing a unit and you can do what you need to without power, shut off all of the power sources and lock out their switches before you start work. Don't forget to shut off and lock out power supply circuits and backup circuits, along with the control circuits. But if you have to work on lines and systems that are still energized, make sure all of your tools are properly insulated and don't wear anything conductive like rings, watches, or keychains while you're working. Wear eye protection in case there's an electrical flash or spark. And always have a heightened sense of awareness about the danger around you. Electric arc welding poses a major electrical hazard. Welding units often use thousands of times the amount of current it takes to kill a person. So make sure that the welding unit and the work itself is grounded, and that you stay insulated from the circuit. Check to see that your electrode holders and welding cables are well insulated and that the stinger leads aren't damaged. You should be extra careful when changing electrodes and avoid using your bare hands. Also, arrange your cables so that they're protected from hot slag and sparks. Cable insulation can melt if it's not properly protected. And remember, water is an excellent conductor. Whenever possible, avoid electric arc welding in damp or wet environments. If you have to work in that kind of situation, protect yourself against becoming the easiest path to ground by using welding mats for extra protection. Without electricity, we couldn't do our work, so it's important to be aware of the dangers at all times. By understanding the concept of ground, by making sure your power tools and equipment are in good condition, by using GFCIs, and by recognizing hazardous situations, you'll keep electrical safety high on your priority list. Electricity is a powerful and valuable tool. Use it safely and make sure that you never, ever become electricity's path of least resistance to ground.